This is an Australian black rock scorpion. While it may look scary, and though it can give you a nasty sting, its venom may hold the key to understanding chronic pain and could lead to non-addictive painkillers of the future. Researchers isolated a toxin from the venom of the Australian black rock scorpion. The toxin activates a protein called TRPA1, or as it's known more commonly, the wasabi receptor. This receptor is found in the sensory nerve endings throughout the body and acts like a fire alarm. Its activation gives you a warning signal that you are being exposed to something dangerous and you need to remove yourself away from it. The same receptor is activated and makes you cry when you're near cut onions, ginger, or wasabi. Once activated, it can cause pain and inflammation. However, the Australian black rock scorpion toxin activates the TRPA1 receptor differently than other compounds. It forces its way into nerve cells and passes directly through the cell membrane. Once it's inside the cell, the toxin attaches itself to the same site on the receptor. But, rather than triggering both pain and inflammation, it only causes pain. That may eventually help researchers figure out how to stop the inflammatory response that's often triggered by chronic pain and develop new kinds of non-opioid painkillers that are non-addictive. Scorpion venom has inspired more than just pain research. Researchers are looking into using a peptide from scorpion venom to suppress immune responses, allowing it to be used in the treatment of autoimmune diseases. Even cancer is beginning to feel the scorpion's sting. A drug called Vitatox is obtained from blue scorpions. It's known as Cuba's miracle drug, and it shows promising anti-cancer activity. It has been tested in more than 10,000 cancer patients. So far, the drug has yielded positive results against various cancers. Scorpion venom may not always be able to help kill cancer, but some venoms are great for helping doctors find the cancer. Researchers have developed a so-called tumor paint using chlorotoxin, a protein found in Deathstalker scorpion venom. The molecule attaches itself only to cancerous brain cells and lights them up through a fluorescent tag attached to the toxin. This enables doctors to pinpoint the exact location and extent of cancerous growths in the body. Now, researchers have discovered a type of scorpion venom which contains two compounds that can kill bacteria resistant to antibiotics. This scorpion, called Diplocentris malici, is native to eastern Mexico and lives underground most of the year, appearing only in Mexico's rainy season. Researchers isolated the compounds of the scorpion's venom and synthesized them in a lab. They then tested the synthetic versions in mice. One compound that is red in color was very effective at killing Staphylococcus bacteria. Meanwhile, another similar compound excelled at killing off regular tuberculosis-causing bacteria. What's amazing is that this included strains of the diseases that had developed resistances to existing drugs. While the compounds were effective at killing off the diseases, they left the mice unharmed. Further research needs to be done to refine these processes, but researchers are hopeful that scorpion venom will help in the identification, treatments, and even cures of many illnesses and ailments.